Okay, hey, I'm Mr. Shrum, and I am back again with another one of these tutorials for the mastery tests, because some of these are a little tough if you don't quite know what's happening. So we'll talk about significant figures, scientific notation, and the basics of math that you'll need in this course. And hopefully this will help with other homework as well. So we're going to start off with number one, talking about significant figures. So if you go through the lesson, you'll learn that when you multiply, divide, or add and subtract, you have to pay attention to significant figures. This term, significant figures. And really that means you can only be accurate up to a certain point in science. Science is all about using the best and most accurate information you can have, and you don't want to overstate your abilities. And we'll get into that a little later. But for now, think of these rules as using the lowest number of significant figures if you're multiplying or dividing. So if we have 67.6 and you're multiplying that by 1.2, you can look at these numbers and count these significant figures. So 1, 2, 3, you're just counting the numbers here. So 67.6 has 3 significant figures. 1.2 has 2 significant figures. Okay? 3, 2. However, when you multiply or divide, you can only use the lowest number of significant figures. 67.6 times 1.2, you'll get 81 if you use the lowest number of significant figures. Because you can't be more accurate than this. Okay, this had 2 significant figures, so you just use the lowest significant figures you're multiplying with. If your first number has 4 significant figures and your second number has 2 significant figures, you still only use 2 significant figures. Okay? And that's for multiplying and dividing. Now the next question, we're adding and subtracting. And if you add or subtract, you're looking at the decimal place or the decimal point. You can only use significant figures past the decimal point. So we're given 24.545 and 307.3. You can only, the answer can only go past the first number past the decimal point. If you add these numbers up, you get 331.845. But because this number only goes past the decimal point by one number, you remove 4 and 5, and you just put 331.8. Okay? Significant figures. If you're multiplying or dividing, use the lowest number of significant figures. And then if you're adding it or subtracting, you're only using significant figures past the decimal point or place. Point 2. And this is, you can only be accurate up into a certain point. So those two are the big sig fig questions. Then we have 3. Let me get more of that in the picture. My microphone. Okay. Let's move that up a little. There you go. There, that's it. So we have a question. Mary walked north from her home to Sheila's home, which is 4 kilometers away. So I drew it out. 4 kilometers north is Sheila's home. Then she turned right and walked another 3 kilometers to the supermarket. So I drew that out too. 3 kilometers, market. And that is 5 kilometers away from Mary's home. Okay, so I drew that out in this dotted line. She walked the total distance in 1.5 hours. So she walked 4 kilometers and then 3 kilometers, all in 1.5 hours. What were her average speed and average velocity? So there is a difference between average speed and average velocity. Average speed is the total distance she actually walked divided by total time. So her total time was 1.5 hours. And her total distance, you add up the 4 kilometers and the 3 kilometers to get 7 kilometers. Divide that by the total time, 1.5 hours. Her speed was 4.6 kilometers per hour, her average speed. However, average velocity is displacement divided by total time. Okay, we have total distance, the distance she walked, but her displacement is the shortest path between her starting point and end point, which is this, 5 kilometers from her home, and she's at the market, okay? So we have 5 kilometers divided by time, that's the same, 1.5 hours. We have 5 kilometers divided by 1.5 hours to get 3.3 kilometers per hour. I made a mark mistake, but it's 3.3 kilometers per hour. And that's her velocity, average velocity. So that would be this one. Average speed was about 4.6 and average velocity about 3.3. So keep in mind that speed and velocity are slightly different. All right, the next couple are about standard notation. And this is sort of a scientific etiquette, the most proper way to write certain numbers, especially if there are a lot of zeros after the, oh, let me make this bigger. There, okay. Especially if there are a lot of zeros after the number, this can be an easier way to write the number, but you have to know what these mean, okay? So we have 9.3 times 10 to the 5th power. And this number here, think of that as moving the decimal point to the right 5 times. And each time you're moving, you add a 0 if there is no number there. So we have 9.3, we move it once to the right, 2 times, 3 times, 4 times. and 5 times. And each time you're moving, if there's not a number there like this 3, you add a 0. So 1, there's already a 3, and then you move 0, 0, 0, 0. And that's the final number. So if you were given this number and asked to write this in that form, you would go here, 9.3, and then you would count how many times you'd have to move to get back to 9.3. It's always a number, point, a number. And if you're moving to the right, this number will be positive, but like in the next one, if that number is negative, that means you're moving the decimal point to the left instead. So let's look at the next example. Number 5. Actually, there's another question, not number 5, but we'll get to that in a second. This is another significant figure question. And after a decimal point, that 0 is a placeholder, so it is actually not significant. However, number 8 and 0 are significant figures. So in certain situations, zeros may count as significant figures or not. So if it's after the decimal point, any 0 between this number and the decimal point is not significant, but any value other than 0 is significant, and then a 0 afterwards is also significant. And I can post significant figure guidebook. I think it's in the guided notes as well, but this is just something you'll get better at with practice. So for instance, 0.0800. So after the decimal point, not significant, but these 3 are. And significant, it means these numbers are stating the accuracy of the measurement. So this one would have 3 significant figures, or sig figs. That's the cool sciencey term for these things. But that would be 3, and then if this were the case, just the 8 is significant. So that would be 160. Okay. But if you're still having trouble with this, I would click or search significant figures help on Google or YouTube and just practice with these numbers, but you'll eventually get the hang of it. Number 6, which is the correct answer. Which multiplier does the word kilo represent? Well, kilo is Greek, and that signifies 1,000. So kilo is the same as 10 to the 3rd power. And that means 1,000. 1,000. And that's just testing your prefixes. So there's a lot. Kilo, centi, milli. Those are the most common you're going to be dealing with, I think. So it'll be 10. But all you really need to know is that whatever prefixes is placed in front of whatever meter, that will change the amount of this unit, okay? So kilometer is 1,000 meters. A centimeter is 1/100th of a meter. So kilo is 1,000 meters. Centimeter is 1/100th of a meter because it's smaller than a meter. And then millimeter, sorry, excuse me, is 1/1000th of a meter. Okay? So that's all that prefixes mean. It just helps you tell how much of a unit there is. 7. Which is the correct scientific notation for 724 billion? You don't even necessarily need to know how the number is pronounced, but you can put the decimal point after the first integer, the first number. So we'll put it here, 7, and then we want 7.24 times 10 to the something, but we don't know what yet. So we're going to start here and then count over to see how many times you need to move the decimal point. So I did it here, but we can do that in a different way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we moved 11 times to the right. If we're going to put the decimal point here after the first number, you move the decimal 11 times to the right. So that will be 7 times 10 to the 11th. Because we're moving to the right, we're moving the decimal to the right. That means it's positive. And then if you have to move the decimal point to the left, that will leave this number negative, okay? But yeah, hopefully you're getting the hang of that type of problem. So this is back with those prefixes again. This will give you the prefix, the letter indicating the prefix, and then that tells you how large the prefix changes the unit. And then ask you, well, what's 1 nanometer compared to a centimeter? 1 nanometer is equal to how many centimeters? So we're putting how many nanometers goes into centimeters. So we'll have nano over centimeter. And then you'll put the number next to that prefix. Okay, so nano over centi, we'll have 10 to the negative 9 divided by 10 to the negative 2. And dividing by 10 to a negative power, or just anything to a negative power, is the same as multiplying it to the positive power. So dividing by 10 to the negative 2 is the same as multiplying 10 to the positive 2. Okay? All I did was move this up here and got rid of the negative sign. And if you're multiplying powers, you're just adding these. So 2 plus negative 9, that is actually 10 to the negative 7 centimeters. Okay? Or you could also use a calculator and just put 10 to the negative 9 divided by 10 to the negative 2, or 0.000000001 divided by 0.01. Okay? And you'll also get 10 to the negative 7 centimeters. So these prefixes are all based around a unit, and then in relation to each other, you can just divide. Oh, it's having trouble focusing. But on these, I would just use a calculator. That will solve a lot of your issues. But don't let these prefixes scare you. Okay, number 9. Ooh, let's get that more straight. There you go. Which measurement is equivalent to 350 milliliters? So we know 350 milliliters. 1 liter is equal to 1,000 milliliters. Milliliters, not millimeters. Incorrect, Mr. Sharon. But so if we know 1,000 milliliters are in 1 liter, how much is 350 milliliters? So obviously that's less than 1 whole liter. So we have 350 milliliters divided by 1,000 milliliters. That equals 0.35 liters. But we need that in standard notation. So if the decimal point, we want the decimal point right there. So 3.5 will be what we start out with, times 10 to something. This decimal point needs to move to the left. So that'll be 10 to the negative 1 liters. 3.5 times 10 to the negative 1 liters. Okay. So here. I'll just show this. Oh, don't pay attention to that. So 3.5 times, this does not have to do with the problem. This is just an example now. But we'll use the same numbers. 3.5 times 10 to 2. That means 3.5. You're moving it to the right 2 times. So that equals 350. But if that's 3.5 times 10 to the negative 2, you have 3.5, but you're moving to the left 2 times. and you're putting the decimal point there. So you'll have 0.035. So you see how those two are different. We're using the same numbers, but this has a positive power and this has a negative power. Positive means you're moving to the right. Positive to the right. Decimal moves to the right. Negative, you're moving the decimal to the left. Hopefully that clears some things up for you. And then we have this last question. I think that's too far zoomed in now. Hopefully that worked. All right. So we are back to scalar quantities. Which of these is a scalar quantity? Remember, vectors have magnitude and direction. Scalar quantities have just magnitude, no direction. So we know acceleration is a vector, displacement is a vector, velocity is a vector, length is scalar, okay? Whenever we refer to length, we don't say something negative 30 inches long, right? That it doesn't make sense. It's always a positive measurement. So that is why that has scalar. That's a scalar quantity. There's no direction with length. So hopefully this helps you with the homework. We talked about sig figs, or significant figures. It's one topic. Scientific notation. Scientific, I guess, standard notation. Vectors versus scalar. And prefixes, let's say that. Prefixes. So hopefully that helped you out with some of the more common math equations or situations in physical science. And if you have any more questions, send me a message in Canvas or Admentum, and I will try to help you out that way. But okay, that's all for today, and I will see you guys later.